Welcome back to this lesson. We'll be looking at lesson 8.1 about basic descriptive statistics about language. So here we go. The objective is that students will be capable of producing basic descriptive statistics with the statistics module in Python. So the statistics module has three functions about central tendencies in numbers, right? A series of numbers. The mean is the average, arithmetic average, right? Right. I mean, just to review, you add the numbers up, you divide by the number of numbers, gives you the average or the mean. Median is the middle point. If you take all the numbers and you sort them from lowest to highest, you take the middle point. And if you have an odd number of data points, then it's actually a number. If you have an even number of data points, then it takes the mean of the middle two. The mode is the most frequent number, which may or may not be a good measure. It may or may not be a good measure of central tendency. Anyway, mean and median are the most common, with mean being the most common, the average, right? The arithmetic average. There are other averages, by the way. There's like geometric average, which is a different way of calculating central tendency. And then there are also some functions that deal with dispersion, that measure dispersion or spread around the central tendency, like how far spread around the central tendency are the numbers. Standard deviation is a really common one. And so it's a mathematical thing. It's not too complex, but it's mathematical calculation to get the standard deviation. Variance is simply the square of the standard deviation. You can get the range, which is simply the max number minus the min number. That gives you the range, right? So that's when you're dealing with a series of numbers. So for example, if we're looking at word length of sentences by author, you know, Jane Austen versus Mark Twain, do they have any differences on their sentence length and number of words? We would need to count up number of words and sentences and you know, do some type of central tendency measurement and dispersion measurement. Okay, so that's exactly what we're gonna do. Let's practice this. So download or reuse a TXT file of a novel of your choice from Project Gutenberg. And then calculate the measures of central tendency and measures of dispersion for sentence length. At least these two here, don't worry about the range, standard deviation and variance. Okay. Hint, it might be easiest to read in the whole string, or excuse me, the whole file as a string with the .read method on the file handle or the file object. If you need to review about how to read in files, we looked at that right here at 5.1, file handling. Just a real quick review. There are like 4 different ways you can read in a file once you have a handle, a file object handle on it. The .read returns the whole file as a string, right? I often use the for loop on the file handle to loop over line by line. But anyway, I would recommend, it'd probably be easiest to use this one right here, to read the whole thing as a big string, the whole novel as a big string, and then to divide up that big string based on at punctuation that represents the end of sentences, right? And use the re.split function to break up that big string on punctuation that represents the end of a sentence in English. Okay, I'll just leave you there. I'll leave it there and encourage you to give that a try. Take a few minutes and give that a try. Ready, set, pause. Okay, I assume at this point you are skilled at Googling help about Python. Like, you know, simply Googling Python statistics mean. How do you use this thing again? You know, and just looking at what people ask online, looking at the documentation. This first one was the documentation for this module. I assume at this point, maybe I shouldn't assume, but you need to be able to Google things, right? Just Python, the name of something you need to, like the function or the module, and just get skilled at looking at Documentation examples, just kind of skimming down. Okay, how are they doing this? Okay, they have a list of integers and they just pass that into the mean function here. But how are they importing it? Well, they're importing it, a certain way. So that said, let's take a look at how to do this one. Once again, you're going to download or use a TXT file on your hard drive of some big TXT file, whether novel or something big. Calculate the measures of central tendency and the measures of dispersion for sentence length. Okay, let's take a look at that. So here I'm going to use my old friend Jane Austen, Pride and Prejudice, .txt on my hard drive. Okay, the first thing I need to do before that is to import the statistics module, as well as RE, the RE module, our old friend as well. We're going to use RE.split down here. And we're going to use statistics down here with these functions that's in the statistics module. So you first import those two modules. You can separate them by a comma or put them on separate lines as two different import statements. Then I'm going to create an empty list. Let me zoom way in so you can see that that's an empty list. I have square brackets, so I'm creating an empty list there. Then I'm going to open up a file handle connection to this prideandprejudice.txt, save it as a variable. Fin, because I did not specify the mode, it's going to read in. That's the default. And then here is where I'm going to use the .read function on this method on this file handle. So I'm going to read the whole novel in as one big string. Save it to a variable called novel. And then I'm going to split up that big string on punctuation that represents the end of sentences in English. So once this is regex, right? This is a regex syntax here, right? RE.split is a regex function. The first argument is the regex itself. Here I have R, double quote, character class between square brackets, right? So I say split up either on an actual period. The backslash means it's an escape character. It says I want an actual period, because normally in regex language, a period just means any character, but I actually want a period. And then the backslash question mark means an actual question mark. Again, that backslash is an escape character, which means I actually need to see a question mark, not what question marks usually mean in regex language, which is 0 or 1 of the previous thing. I actually want a real question mark. And then exclamation point here as well. So those three punctuation marks identify the end of strings in English, right? So I want you to find, so I'm saying I want you to find those three things and split up this big massive string, which is the whole novel, at those points. And so I'll end up with the list with each element of that list as having a sentence, right? Each sentence will be in its own element in this big massive list. Okay. And if you want, I can even show you that. Let me just print this out. Print sentences. And let me not run anything else below this point. Let me just comment all this out. Let me do a quicker comment way. Let me show you, if you were to do a doc string like this, triple quotes, triple double quotes, and then jump to the bottom of the script, and then do another triple quote. That would comment out all this stuff right here. So if I run that, let me just see what happens. Okay, there we go. So yeah, we have a list down here. I'm looking at the console in the bottom part of my screen. Let me jump to the very top. Right in here, there's some junk. This is a byte or order marker thing. Anyway, yeah, so each of these, we have a list here, and each element of this list is a sentence. There's a second sentence starting right there. That's the header of the Project Gutenberg. But the idea is that we took the big massive string, which is the whole novel, and we broke it up at punctuation that represents sentences, that represents the end of a sentence. Okay. Good. So let's comment that out and let it just go. Well, let me explain the code before I let it go. All right, so we now have a list of sentences. So let's loop over, and it's in a list called sentences, very transparently. So we're going to loop over this list, and we're going to use the variable sentence singular as the variable that's holding each sentence in turn as we loop over this list. We're going to split up on white space. The default for split is white space there. I'm just using the base Python string method split rather than the RE split one now. I'll just let it split up on white space, and that's what this string method does. So here's the sentence variable name that's holding the current string, split it up on any white space, and that should give us some words. And then we want to take this list, and we created an empty list up here. I didn't really stop to comment on it, but there's an empty list here on line 2. We're creating a variable called sentence underscore lens equals square brackets there, which means empty list. And then we want to append to that list the length of words in the current sentence, right? Because this right here, line 7 will give us a list with the words of the current sentence. And we just want to know how many there are. So we just say length, how many are there, how many words are there in the current sentence? And append that to this list called sentence underscore lens for lengths. That's what that stands for. Okay, and then here's a little printout statement to the user saying, I'm going to print out some info about Pride and Prejudice now. And then I just do a little thing here. So I just say print mean sentence length. I use the statistics module, the mean function, and then I just pass in the list that has a bunch of integers. Just has the number of words in the current sentence. Let me just print out real quick what that list sentence lens for lengths has in it right now. Let me just let that go. And so it creates a list right here with the number of words in each sentence. Some of this stuff is not real. Some of these things are not real sentences, right? There's the header and footer and other things, and maybe it didn't split correctly. But you can see it has a bunch of integers. This list is just a bunch of integers that are the length of words, the length of sentences in number of words, right? So then I just pass that list into this function, these functions, mean here, median, mode, etc. All right, let me make this a little bit like that. Okay. So I just pass it in. I just pass that whole list into that and say, hey, give me the mean of all these numbers. What is the mean? And what is the median? What is the mode? What is the standard deviation? What's the variance? And then I just have it print out next to a little informative little title thing here. So info about Pride and Prejudice by Jane Austen. Mean sentence length is 17 words, 17.13 words. Median sentence length is 13. So the middle integer is 13. The mode, that's not surprising. The mode is not really useful here. What is the most frequent sentence? And there's no two sentences that are identical. So that just means one. But anyway, mode's not very useful here. Standard deviation of sentence length is 14.5. Variance is massive, 211. So there you go. That's how you do that to get some information about sentence length from a novel, right? The idea, once again, is simply you bring it in, you read in the whole novel as a string. You split up on punctuation that ends sentences so that you have a big list. Each element of that list is one sentence. And then you break up those sentences on white space to get words. Hopefully they're only just words. And then you just get the length. How many words? Just get the length of that list. That is how many words are in the current sentence. Add it to this list that we're going to collect all the sentence lengths in. Once that's all done, mind the indentation right. We're done with all that work. And then we just use that list to get the descriptive statistics. So that is how you would do that one. So if you like to pause the video or look at the solution file to make it work on your end, I'd encourage you to do so to make it really work on your computer before you move on. Okay. There's another way, by the way, to sentence tokenize. and it's in the NLTK library. There's a cent underscore tokenize. I think I showed this to you in a previous lesson, that this is a nice function that does sentence tokenization really nicely. Okay, let's try this again. Do the same thing with a different author of your choice. And I'm not gonna give you time. It's just, I mean, if you want to stop and do it, but let's just, the idea is it's just identical. So let me just go ahead and show you. The only thing I'm changing this whole script is the novel. So let me just do that real quick. So I'll use Huck Finn by Mark Twain. Do the same thing. All this is identical to the previous exercise. So I'll just run it now. Let me make my console viewable. And we have very similar numbers. I don't know if you remember, but for Pride and Prejudice, the mean sentence length was 17.13, I think it was. And median sentence length was 13. And apparently we have 5 sentences that are identical. Interesting. But very similar numbers. And so the final little exercise here is simply compare, just kind of compare the two novels' sentence lengths. So that is a quick rundown of this little package. This little module called statistics has some nice functions for descriptive statistics with continuous number variables, like a list of a bunch of numbers. Okay. Anyway, this down here, you're just kind of doing it orally. You don't need to do any code. Just, something like Jane Austen and Mark Twain have very similar central tendencies of sentence lengths as measured by mean and median sentence length in words. The mode is different between the two authors. However, this length of Mark Twain's sentences vary more than Jane Austen's because the standard deviation is higher, as seen with the larger measures of dispersion, standard deviation, and variance. So that's all I'm trying to get at with that last little practice exercise, is just simply kind of interpreting it into prose for the human. Okay, so good. At this point, you should be able to, or at least see how you could, if you want to practice it and get it really down, that'd be a good idea. How you can, how you're able to produce basic descriptive statistics with the statistics module in Python. Okay, so that brings us to a conclusion of lesson 8.1 on basic descriptive statistics with that module. See you next time.